Statsproblems.com was used to create this tutorial, which can help us calculate an independent measures t-test, but with less calculation than a complete t-test. Let's begin by selecting one of the 25 example problems. The question appears in the blue box. A set of population scores is normally distributed. Sample information from two unrelated groups appears below. For Group 1, sample size, N1 equals 12. Mean, X bar 1 equals 67. Sample estimate of the population variance, S1 squared, equals 76. For Group 2, sample size, N2, equals 9. Mean, X bar 2, equals 63. Sample estimate of the population variance, S2 squared, equals 57. Alpha is 0.05. Number of tails is 2. What are the results of the hypothesis test, comparing the sample means of the two groups to each other? Let's step through the solution by clicking on the Next Step button. In Step 1, we calculate the pooled variance, S squared pooled. First, we calculate the degrees of freedom for the two groups. Degrees of freedom for Group 1, df1 equals sample size of Group 1, N1, minus 1 is equal to 12 minus 1 is equal to 11. Degrees of freedom for Group 2, df2, equals sample size of Group 2, N2, minus 1 is equal to 9 minus 1 is equal to 8. Now we calculate S squared pooled. S squared pooled equals variance of Group 1, S1 squared, times the degrees of freedom for Group 1, df1, plus variance of Group 2, S2 squared, times the degrees of freedom for Group 2, df2, divided by df1 plus df2. In this example, S squared pooled equals 76 times 11 plus 57 times 8 divided by 11 plus 8, which works out to 836 plus 456 divided by 19, which works out to 1292 divided by 19, which works out to 68. In Step 2, we calculate the difference of the means, X bar 2 minus X bar 1. In this example, the difference of the means, X bar 2 minus X bar 1, equals 63 minus 67, which works out to minus 4. In Step 3, we calculate the estimated standard error of the difference of the means. Estimated standard error of the difference of the means, S sub X bar 2 minus X bar 1, is equal to the square root of S squared pooled divided by the sample size of Group 1, N1, plus S squared pooled divided by the sample size of Group 2, N2. In this example, S sub X bar 2 minus X bar 1 equals the square root of 68 divided by 12 plus 68 divided by 9, which works out to the square root of 5.667 plus 7.556, which works out to the square root of 13.223, which works out to 3.636. In Step 4, we calculate the t-value of the difference of the means. The t-value of the difference of the means is equal to the difference of the means divided by the estimated standard error of the difference of the means, Sx bar 2 minus X bar 1. In this example, the t-value of the difference of the means is equal to minus 4 divided by 3.636, which works out to minus 1.1. In Step 5, we find the critical t-values. There is no previous evidence, or previous evidence is inconclusive. The rejection regions are below the negative critical value in the lower tail and above the positive critical value in the upper tail. We need degrees of freedom to look up t critical value. Degrees of freedom total, df tot, equals the degrees of freedom from both groups added together, which is df1 plus df2, which is 11 plus 8, which works out to 19. With tails equals 2 and alpha equals 0.05, we need to look up critical value for df equals 19. Use Interactive Table 7 to find the critical value. With two tails and alpha equals 0.05, and df equals 19, use t equals 2.093 from the lookup table. We close this window to return to the analysis, which shows the negative critical value is minus 2.093 and the positive critical value is 2.093 with two tails and alpha equals 0.05. In step 6, we test the hypothesis. The t-value of the difference of the means, minus 1.1, is between critical values of minus 2.093 and 2.093, so fail to reject the null hypothesis. In addition to the 25 example problems, we can work step by step through an unlimited number of new problems using the Generate button. The Edit Data button can help us create problems with customized input. Instructors can use this function to create problems with complete solutions to use on exams, in class, or for homework. For printed output, we can print the question. Or we can print the question with the complete solution. The free website has statistical analyses in all of the most common areas in statistics. Statsproblems.com also has a mobile version so you can access the site from anywhere. For help with statistical concepts, HelpMeWithStats.com is a free website that has more than 70 tutorials, as videos, or as self-paced slideshows. In addition, HelpMeWithStats.com gives you free access to a comprehensive stats textbook with more than 685 review questions. Thanks for watching. If you find these resources valuable, please share Statsproblems.com and HelpMeWithStats.com with your friends and instructors.